Welcome back to the course entitled Chemical Crystallography. In the previous class, we were discussing about how to draw the stereographic projections of various crystallographic space groups. So in that, we have discussed the projections of the space groups P212121, CMM2, P4 and I4 space groups. So in this lecture, we are going to discuss about a few important space groups. So we will first talk about P41, then we will elaborate to I41, and we will compare what is the similarity and difference between P41 and I41. Then we will learn how to draw P4 bar, P4 by M, and then I4 by M. And by doing these space groups, I will show you how this P4 by M and I4 by M can be drawn with a slightly different notations, which are also given in the International Table of Crystallography. So let us start today's discussion with the space group P41. So as we can see, this is P41, which indicates that it is a tetragonal space group because it has a 4-fold symmetry, and 4-1 screw is possible in a tetragonal system. So as a result, we should consider this 4-1 to be parallel to z-axis, and the projection should be done in the AB plane or the XY plane. So I am now trying to draw the XY plane, which is a square shaped plane. So I have drawn the square shaped plane here with, suppose, this direction as B and this direction as A. So now if I use the letter P, you remember this is a primitive lattice. So I have the object associated with the corner. So I should draw the translation related objects, as always we should do, and then see where the 4-1 screw should come. You see the 4-1 screw should come perpendicular to the plane of projections, that is the along z axis or along c axis. So we should draw the 4-1 screw at every corner with correct direction. This is the notation of 4-1 screw, as you have already learned. So first thing is to draw the symmetry elements at its correct location. So as a result, what we see is, because of this 4-1 screw going along z-axis, we should start writing the equivalent points or drawing the equivalent points around this 4-1 screw. So the point from first point, which is point number 1, if I do a 4-1 rotation, the letter would move here with 1/4 translation. Then, so this point is number 2. Now I rotate this point by another 4-1, which basically means that rotation by 90 degree and translation by 1/4. So this is plus half. So this point is point number 3. And then again the fourth point is nothing but plus 3/4 is point number 4. So there are 4 equivalent points around this 4-1 screw axis. So we should draw the symmetry related objects as well. So I am quickly drawing the symmetry related objects. Right? So now what we see is that inside the unit cell there are 4 equivalent points. So 1, this is the 4th one, this is the 2nd one, and 3rd one. All these 4 equivalent points are again related by a 4-1 screw about the center of the lattice. That is about this central point. Now what is the relationship between 1 and this point number 3? The relationship is nothing but a 2-1 screw. So at the intersection of these points, rather at the junction, at the midpoint of the axis, you have 2-1 screw that has got generated because of 4-1 screw that is present at 4 corners. So what are the corresponding equivalent points? The point number 1 is of course XYZ. Point number 2 is a 90-degree rotated object with 1/4 translation along Z. So this point will be minus Y X Z plus 1/4. Point number 3 will be minus X minus Y Z plus half, and point number 4 will be Y minus X Z plus 3/4. So these are the corresponding equivalent points for P41 space group. So now for our easy comparison purpose, this becomes P41. We will draw I41 next to it. So again we should draw a square surface or square projection, because we are going to draw the B-axis along this direction, A-axis along that direction, and your C is perpendicular to the plane of projection. So for our easy understanding, we are now going to divide this square again into 4 parts. And as you see, this is 4-1. Just like P41, we should also draw the 4-1 screw at 4 corners. And this being I, we should also start by drawing the 4-1 at the center as well. And you remember that we have point P at the corner and point P which is halfway up at the center as well, because this is I-center lattice, which means you have one object at point number 1 which is x, y, z, and point number I would say 5, which is nothing but x plus half, y plus half, z plus half. This satisfies the condition for eye-centered lattice. So now with this point P1, P, we should draw the corresponding symmetry related objects and then start drawing the 4-1 related objects as we had drawn in case of P41. And also at the center, when you have this P plus half point, so we apply 4-1 there as well. So half plus 1/4 becomes plus 3/4. 3/4 plus 1/4 becomes P. And then P plus 1/4 becomes plus 1/4 here. This is 3/4. So now what we see is between 1, so this is 2, 3 and 4. So this point is nothing but point number 3 and this is 2, this is 4. So between 1 and 3, once again we see that there is a two-fold axis and a translation. So there is a 2-1 screw. So again, just like the previous one, there is a 2-1 screw at the midpoint of the A-axis and B-axis parallel to Z-axis. What else we have? You may notice that between this 1 and this point, which is also 1, they are at same level along Z. So there exists a two-fold axis. Again, between these two, they are at the same level. So there exists a two-fold axis. Here we have a two-fold, and there also we have a two-fold. So this is the difference between P41 and I41. In case of P41, there was no additional symmetry at the 1/4 location, whereas here in case of I41, there is an additional symmetry of a two-fold axis, and it is very easy to write down the corresponding equivalent points. These are the corresponding 4 points, 1, 2, 3 and 4. Then I have already written 5 there. So the point number 6 would be minus y plus half, x plus half, z plus 3/4. Point number 7 would be minus x plus half minus y plus half z, and point number 8 would be minus y plus half, would be y plus half minus x plus half z plus 1/4. So in case of P41, there are 4 equivalent points, z equal to 4, and here the z is equal to 8, because there are 8 equivalent points in the unit cell. So now what I would ask you yourself to compare the stereographic projection of P41 with P4, which was done in the previous lecture, and I41 with I4, which was also done in the previous lecture, and try to understand the differences or additional symmetry elements that are associated with these P41 and I41 compared to P4 and I4 space groups. So now let us try to see what happens when we try to draw the stereographic projection for P4 bar. What does 4 bar mean? 4 bar actually means it is a summation of 4 plus I, that is the inversion center. And once again, this corresponds to a tetragonal lattice. And this fourfold axis is always parallel to C. So we draw B in the right side and A from top to bottom. And we use the symbol for 4 bar as this one. This symbol is the internationally accepted symbol for 4 bar axis. So first thing first, we should draw the notation for the symmetry element, that is 4 bar. And then we draw the corresponding object P, which is our point number 1, and the corresponding translational components as usual, as we always draw the translational components. So then you do a 4 bar operation. What does it mean? 4 bar means it is 90-degree rotation followed by inversion. So if you first rotate it by 90 degree, you get here, and then by doing inversion about this point, you get the object down. So if this was a plus, that means above the plane of projection, 90-degree rotation kept it as plus, and then on inversion it has become a minus. So this is point number 2. Now again we do this 4-1 operation on this minus object. So you rotate it by 90 degree from there, it comes here. As you see, the point is here minus, so when it comes here as minus, and then the inversion takes it to the other part and converts it into plus. So this is the 3rd point. And then again you rotate this object by 90 degree and come here with a plus sign, and then on inversion it goes there with a minus sign because it originally was plus, but now after inversion it has become minus, and that is the number 4. So we do the same and at all the points. I am doing it quickly because I have already explained how this happens. I want to then show you what are the other symmetry elements that got generated because of these four symmetry related objects. So for that I need to divide this square into 4 parts. Now what is the relationship between this point number 1 and which is essentially a point number 3 here? This point and that point are at same level, plus. So it is, don't get confused, as it is minus, it is plus. And hence there is a symmetry element of 2 1 screw at the central point. So every edge, the midpoint of the edge is a two-fold axis, and then what we see is that between this and that, which is 1 and 3, and then between this point, which is 4, and that point is 2, it is exactly like the 4 bar point. So we should also draw a 4 bar axis at the center. We see that if you rotate it by 90 degree, it goes there, and on inversion it comes here. You rotate it by 90 degree, it goes there, but then on inversion it comes here. So the plus which was here on inversion becomes minus. This minus goes rotated at this point and gets inverted here, so it becomes plus, and so on. So what are the corresponding equivalent points for these 4 points, 1, 2, 3 and 4? So the point number 1 is of course x, y, z. What is point number 2? What we have done in case of point number 2, we have rotated by 90 degree, that is it has become minus y, x, z, and then we have applied I to it, which has essentially made it y, x bar, z bar. So this is the coordinate of 2. Then point number 3 is a 4-fold rotation on point number 2, which gives you a point which is x bar, y bar, z on inversion, and then the corresponding point 4 is nothing but y, x bar, z plus inversion. That means this point is y bar, x, z bar. So these are the 4 equivalent points in case of P4 bar. So let us parallelly check what happens if we try to do the space group I4 bar. So first thing first, we should draw the 4 bar axis, considering this as the V direction and that as the A direction. And as usual, we should divide this into 4 parts for our easy understanding, and we will have the 4-bar axis in the middle as usual. Now this is, you remember that this is lattice, that is body centered lattice. So when I have this point P at the corner, I should have another point at plus half as well. And this point will be the point number 5. So we draw the corresponding 4-1 related objects, sorry, 4-bar related objects. So this P, which is of course plus, comes here as minus. This is my point number 2. Then this goes and comes here as plus, which is point number 3. And then this comes here and gets inverted as minus, which is point number 4. Similarly, we should draw all the translation related objects. Now we should apply the 4-bar at the central point as well. So from here it should get rotated there with a plus half, and then on inversion it should become minus half here. So this is your point number 6. Then you do the same operation, rotate and invert. It goes there as plus half, and then it goes here as minus half. So this is 6, 7 and 8. So what are the equivalent points for this I4 bar? Point number 1 to 4 are same as P4 bar, and 5 is x plus half, y plus half, z plus half, and then you should follow the symmetry elements and then write down the corresponding equivalent point as you see here. So 5 to 6 has a minus, so that z is minus, and this is on the negative side of y, so it should be from here, if you go there and then this point becomes x bar, so minus y x z, and then on inversion it becomes y plus half minus x plus half minus z plus half. Point number 7 will become minus x plus half minus y plus half z plus half, and point number 8 would become minus y plus half x plus half and minus z plus half, because that is on the negative side. So now what is the relationship between this 1 and 3? This 1 and 3 are related by a two-fold axis, which I am drawing in a different color. So that is a two-fold axis which is generated. And what is the relationship between this 1 and 7? They are related by a 2-1 screw in the middle. So this is a new symmetry element that got introduced in case of I4 bar. So P4 bar and I4 bar share a lot of similarity in terms of the axis, in terms of the symmetry element that got generated along the edge, but I4 bar has an additional symmetry of 2, 1 parallel to Z, passing through x plus 1/4, y plus 1/4 kind of locations. That is x plus 1/4, y plus 1/4 is this one, this point is x plus 1/4, y plus 3/4, this point is x plus 3/4, y plus 3/4, and this is x plus 3/4, y plus 1/4 locations. So you can understand how slowly, with the knowledge of your crystallographic projections, you can start drawing some difficult crystallographic space groups in a two-dimensional projection. So let us now try to understand the projection of P4 by M and I4 by M. So what does it mean? It means a fourfold plus a perpendicular mirror. That means wherever I have the object located at some height of Z, the mirror is perpendicular to Z. So at the same point we should have the minus object as well. So when we say P4, so I should first draw the 4 at all the points. And by M means this particular plane which I have already drawn is my mirror plane. So I am drawing the mirror plane as a bold line, which indicates that this particular plane is a mirror plane. So now if I try to draw the objects, when I say this is plus, which means above the plane of projection, then I draw the 4 with this plus. It is nothing but similar to P4. Now if you consider the mirror, so the mirror is perpendicular to Z axis. So whatever is plus, because of the mirror, will have its mirror image just below that. So everything will become plus minus. Plus and minus means the same amount up and down, that is above and below the plane of projection. So what we see here is, if we now divide this square into 4 parts, we see that the points which are here as 1, 2, 3, 4, and the mirror images which are 5, 6, 7 and 8. So this point is 3 and 7, 1 and 5. So they are related by a two-fold axis here. These are all two-fold axes. And the corner points are related by, again, a four-fold axis. Right? So these equivalent, there are 8 distinct points in the unit cell, each associated with the corner with plus and minus sign. So there should be 8 equivalent points. So those points, as you know, should be written very easily. So x, y, z. I'm writing the equivalent points for P4 first. So these are P4, and the corresponding pi m, that is mirror perpendicular to z, makes it x, y, z bar. 6 becomes y bar, x, z bar. 7 becomes equal to x bar, y bar, z bar, and 8 is nothing but y, x bar, z bar. So what we see is that 1 and 7 are related by inversion center. 2 and 8 are related by inversion center. 3 and 5 are related by inversion center. 4 and 6 are also related by an inversion center. So this is a centrosymmetric space group compared to the previous ones, which all of them were non-centrosymmetric or rather chiral space groups. So now if we try to draw the corresponding I4 by M in the same line, let us see what new symmetry elements we get by drawing this I4 bar. Sorry, I4 by M. So my object is here with plus sign, and the inversion related object which is plus sign and halfway up along Z. So you draw the corresponding 4 related objects, and then you apply the by M, so it becomes plus minus, plus minus, plus minus, as we had drawn it in case of P4 by M. Right? So the corresponding, this also we should write. So now what we see here is that just like before, the two-fold axis is generated at the center of the edges as usual, like just like in P4 by M. And now between this point and this point, there is a translational relationship of half, which means there is a 2-1 which has been generated at the 1/4 location here. Right? So I would not try to write down the equivalent points. Only I would say that here Z is equal to 16, because what you see is that every corner has 2 atoms associated, so 8, and the central part, which is half translated, that is the body center point, also has 8 equivalent points, so total 16 equivalent points. So I would like you to write down the equivalent points 1 to 16 and see which ones are related by center of inversion and so on yourself, so that you can learn and understand it better. So we will continue in the next class from this point. Thank you.